Hello everyone, I am Zach Peterson. Welcome back to my channel. Today we're going to be looking at how to add EMI filter circuits to AC inputs on your PCB. Now this video was inspired by a recent ESP32 design review video that I did for Raul Rodriguez. And his ESP32 board brought in AC power, and of course I didn't see any EMI filtering on it, so I thought we would take the opportunity in this video to discuss those types of circuits. What we're going to do is take a quick look at Raul's board, and then we'll look at the general topology for EMI filter circuits that are used on AC inputs, and then we'll take a look at some actual circuitry that I've used and that other companies have used in their reference designs. Let's go ahead and get started. Now before we start discussing EMI filter circuits on AC inputs, let's take a quick look at that design from Raul Rodriguez. Here I have the design open in OSHW Lab, and you can see here that this is the Smart Switch C3 module. If we take a look at this picture of the design, it looks pretty nice. It's got a little screen, it's got a custom enclosure, and then you can see here in the upper left corner we have screw terminals to bring in our AC inputs. You can see we have the line, neutral, and ground indicated in silkscreen on the design. Now, depending on the amount of power you need to bring into a design like this and just how much current you're going to be using is really going to determine what types of components you're going to use in your EMI filter. But these filter circuits do generally have a topology that you can follow, and you can then replicate it out to multiple stages if you need to. If you take a look at the PCB, you can see here when this comes in, the design has the AC power going directly over to this AC to DC converter module. Now if we just move a couple of things around on the top layer, we would be able to move this converter module over to the right. We could probably take this relay and move it down, and then that would make enough room for an EMI filter circuit. So now with that little bit of review out of the way, let's take a look at some EMI filter circuit options. We're going to hop onto the whiteboard, and then we'll take a look at a reference design, and we can see a real EMI filter circuit with some part numbers that you can use in one of your designs. So the basic EMI filter circuit topology that we want to use with an AC input is going to be a low pass filter. So first we have our line input, and then we have our neutral, and we're going to come in and first go to a line-to-line capacitor. So that's the first thing we're going to hit. And then if we're doing low-pass filtering, we generally would like to do a pi filter because that's going to give us much stronger roll-off at high frequencies. And so instead of just throwing an inductor here, we want to filter the noise on both lines. And essentially what we're doing is we are trying to filter common mode noise. So if we're filtering common mode noise, instead of just using a single inductor, we want to use coupled inductors as a common mode choke. So to do that, we're going to just draw out my very poorly drawn common mode choke coils here. And we then also want to indicate the polarity right here. And then that tells us that this is a common mode choke. And then finally, we can complete this pi filter just with another capacitor here. This is going to be a line-to-line capacitor. And then that is the basic EMI filter circuit. Now, of course, we could repeat this if we want. We could cascade these filter stages, and that's going to give us even higher order filtering. Again, that's not typical. It's something that you might do when you have higher current or higher power demands, and that's certainly something that we'll see in the reference design that we're going to look at in just a little bit in this video. Now, one thing that, of course, happens with AC power is that you're not just dealing with line and neutral, but you can also have an earth connection. So the earth connection comes in and has to connect somewhere. And the way we use the earth connection when we have an EMI filter circuit and we're using capacitors as part of that filtering is we're using line to ground capacitors. And so in this case, the earth connection is our ground, and then we use some capacitors that then connect each of these lines to earth. And so this is our basic EMI filter circuit. So what I'm going to do here is just draw our earth symbol just for a moment, because we then can use this same connection over here on this side of the filter circuit. So then we also want to use line to ground capacitors here. And then this is also going to connect to our earth connection, okay? And then this would be our AC out, which is filtered, and then that can go to our rectification stage. So here, because we have the earth symbol on both of these nets, we then of course are going to connect these together on the PCB, and that is going to be our high frequency dump back into earth. Now, what types of capacitors are we typically using in these applications, and how big does this inductor need to be? Well, there's a couple things we have to consider here. First is that we're trying to let in a 60 hertz signal, but we want to filter at much higher frequencies than this, or harmonics of this. So we need to get that cutoff frequency for this filter circuit pretty low. And that means you're going to use a pretty large inductor here, or inductance, I should say, on this common mode choke. So the inductance of this choke could be on the order of about a millihenry. So those are pretty big chokes. Now, the other thing that we have to notice here is these capacitors and how these are used. This is a line-to-line capacitor. And when we have line-to-line capacitors, those are normally X-type or class X capacitors. So these class X capacitors are specifically used in these line-to-line applications. What about these line-to-ground capacitors? Well, when we have line-to-ground capacitors, these are class Y capacitors. So typical values for these types of capacitors are about 100 nanofarads to 1 microfarad for the class X capacitors. And then for the class Y capacitors, it's typically 1 nanofarad to maybe at the very most 10 nanofarads. But typical value that I use in most designs and that a lot of reference designs will use is actually 2.2 nanofarads. Now, obviously, these aren't very large capacitor values, but what we do have to have here is very large voltage withstand values that these capacitors can withstand. First of all, we're dealing with an AC input, so of course there's going to be a high peak voltage at 60 hertz, but we also need to make sure that we can withstand a certain amount of voltage, typically in the kilovolt range, depending on which safety standard we're working under. So depending on the class of X or Y capacitors, some of your voltage withstand values could be all the way up to on the order of 8 kilovolts. So that's one of the reasons that these capacitors can be very physically large. It's because they have to withstand pretty high voltages. So as we can see, we've got a pretty large common mode choke as indicated by this inductance value, and then we've got multiple large capacitors that we have to fit into this design. So it's really up to you to determine whether or not these filter components are going to be the best approach for your particular design. In the case of our smart water pump controller design, we have an AC pass-through. So whether or not we need to use these components and the amount of current and voltage they need to withstand really depends on what that power is going to end up connecting to downstream. And in a lot of cases, it might make more sense to put this filter circuit on that downstream unit that this device is going to connect to. If there is a problem with conducted emissions coming into and out of the design and you just don't have any room to fill all these filter circuit components, typically what someone will do is they might try to use a ferrite cuff on the input and output lines in the design. So that covers the basic topology of these EMI filter circuits and what these different components are. Now let's take a look at an example from a Texas Instruments reference design. We're going to hop on the computer and take a look right now. So what I want to do now is just take a look at an example EMI filter circuit that can be found in a reference design, and I have used this type of EMI filter circuit in some of my designs, so you can follow this example. Now what I'll do is I'll also include a link to download this example circuit and all of the CAD data in the video description, so make sure to check that out if you want to get this circuitry. So let's take a look here on screen. You can see I'm inside of Altium Designer, and you can see here where we have an AC input defined right here in the left side of the schematic. We have a connector where our AC input comes in. Here we have a fuse holder. Here you can see we have our earth connection defined. And then here, as we scroll to the right, we then come to our EMI filter circuit, which is then placed before our rectification stage. So here you can see when we come in, we have our capacitors that are connected to earth, and then we have our capacitors, our line-to-line capacitors here at C9 and C52, and then here we have our choke. Now here, this is a 3.3 millihenry choke, so that's a pretty big choke, and that's because this is for a high power DC-DC converter. Now here again, we have the same circuit stage replicated one more time, as you can see here. So this is actually a higher order filter than you would normally use on a lot of designs. So you've got a lot of low pass filtering on the front end of this design. Now just to give you an idea of the size of the components that are used in this design, let's take a look here at C52 and L3. So here, the capacitor for C52 is one of these EPCOS TDK capacitors. This is a film capacitor, and if we just zoom in, you can see how big this capacitor is. So this is a sizable capacitor. It's a through-hole component, and the same goes for that common mode choke. Here, this common mode choke is available from Worth Electronic. If I just click on the image, you can see the size of that choke and how big it is. So again, this is pretty typical for the case where you're dealing with a high-power DC-DC converter. Now again, we also have a mix of Y-type and X-type capacitors. Those different types of capacitors have different safety ratings, and you need to pick those capacitors such that you satisfy the safety rating that you're trying to target for your particular design. So a lot of those fall under an IEC standard, and the various class X1 or X2 type of designations for safety capacitors, as well as the Y1 and Y2 designations, are also defined in those IEC standards. They are based on a high voltage withstand, so what is a peak a voltage that those capacitors can withstand, and those are required to withstand that voltage without failure. So those are in the high kilovolts levels. Now just for some additional assurance in this design, we also have a fuse holder right here. This fuse holder is some additional circuit protection. Just in case one of these capacitors does fail to short, then it is going to short out that fuse, and that's going to protect the rest of this system. So like I said earlier in the video, I'm going to make this circuit available in a downloadable link. I'll put it in the description for this video. Make sure to check out the link in the description, and you can get access to all of this circuitry and all of the CAD data. You can start using it in your designs. Thanks everyone for watching this video. We always get some great inspiration from all of your design review requests, so feel free to find me on LinkedIn and send me your request for a design review, and it just might end up on the Altium Academy channel or on this channel. Also, make sure to hit the like button, hit the subscribe button, leave your comments and questions in the comments section, and if you ask a great question, it just might end up in one of these videos. Thanks again for watching everybody, and we'll see you next time. Thank you.